A computer is an electronic device that processes data and executes instructions to perform a wide variety of tasks. At its core, the Central Processing Unit, CPU, acts as the brain, handling calculations and logical operations through its Arithmetic Logic Unit, ALU, and Control Unit, CU. Data is temporarily stored in random access memory, RAM, for quick access, while long-term storage is provided by hard drives or solid-state drives, SSDs. Input devices like keyboards and mice allow users to interact with the computer, while output devices, such as monitors and printers, present the results of the computer's processing. The computer operates through a systematic cycle of input, processing, storage, and output. Users input data, which the CPU processes according to instructions retrieved from memory. The results can be stored for future use or displayed to the user. The operating system manages these resources, facilitating interaction between hardware and software. Computers are incredibly versatile, finding applications in productivity, communication, entertainment, and data analysis, making them essential tools in modern society. A transistor is a semiconductor device that functions as a switch or amplifier for electrical signals, operating on the principle of controlling the flow of current between its three layers: the emitter, base, and collector. In bipolar junction transistors, BJTs, which can be configured as either NPN or PNP types, a small current at the base controls a larger current flowing from the collector to the emitter. This current amplification allows transistors to take a weak input signal and produce a much stronger output, making them essential for signal processing in electronic devices. Transistors also serve as switches in digital circuits. When a sufficient voltage is applied to the base, for BJTs, or to the gate, for field effect transistors or FETs, they allow current to flow between the collector and emitter, or source and drain in FETs. This on-off behavior enables transistors to control larger currents, effectively acting as binary switches that represent the zeros and ones of digital logic. Their ability to amplify signals and act as switches underpins much of modern electronics, from computers to smartphones, making transistors fundamental to the development of integrated circuits in various electronic applications. The NOT gate is the simplest logic gate and works with a single input. Its function is straightforward. It inverts or negates the input value. If the input is 1, the output becomes 0. Likewise, if the input is 0, the output flips to 1. You can think of the NOT gate as a basic switch. Whatever signal goes in, the NOT gate returns the opposite. Next, the AND gate operates with two inputs. Its job is to produce a 1 only when both inputs are also 1. If even one input is 0, the output will be 0. This gate represents the logical AND, meaning both conditions must be true for a true output. So when you see an AND gate, think of it as a filter that only lets a 1 through when both inputs match. Finally, we have the OR gate. Like the AND gate, it takes two inputs but works differently. The OR gate will output a 1 if either input is a 1. It only produces a 0 when both inputs are 0. The OR gate is useful in cases where either of the conditions can be true for a true outcome. Picture the OR gate as an either-or decision maker, allowing more flexibility than the AND gate. In short, computers use millions of transistors working as tiny switches to process information. With basic logic gates like NOT, AND, and OR, transistors combine to form complex circuits, enabling everything from calculations to AI. These building blocks are what make modern technology possible, driving the digital world around us. In this digital age, that is all. Thank you for watching.